Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. The minimum force required to break a particular type of cable is normally distributed with mean 12,432 and standard deviation 25. A random sample of 400 cables of this type is selected. Calculate the probability that at least 349 of the selected cables will not break under a force of 12,400. Let us write y for the minimum force required to break a cable. So we are told that y is normal with mean 12,432 and standard deviation 25. Therefore, the probability that a randomly selected cable will not break under a force of 12,400 is the probability that the minimum force required to break that cable is more than 12,400. So the probability that y is more than 12,400, which is the probability that a standard normal random variable, which you obtain by subtracting from y its mean and dividing by its standard deviation, so subtracting 12,432 divided by 25. So the probability that standard normal is greater than 12,400 minus 12,432 over 25, and that's the probability that z is more than negative 1.28, which from the table we'll quickly get that this is 0.9. So the number of cables, so this is for an individual cable. Okay, again, this is the probability that the cable will not break under that force. So each cable is like a Bernoulli trial with a probability of success that is not breaking of 0.9. And then the number of cables that will not break has the binomial distribution with n equal to 400, because we're looking at 400 cables, and with every one of them we want it to not break. So we want success, which has probability 0.9. So we want the probability that n is greater than or equal to 349, at least 349 successes out of 400 attempts. And of course, it would be complicated to calculate it using the binomial distribution directly, but binomial is a sum of independent, identically distributed Bernoulli trials, so as such, it can be approximated by normal distribution based on the central limit theorem. And so we use that approximation, except we do a continuity correction because the normal distribution is continuous and binomial distribution is discrete. So the probability that n is greater than or equal to 349 is the same for this discrete distribution. It is exactly the same as probability that n is greater than 348.5, but that provides a better approximation if we now switch from n to a normal distribution approximating n. And that normal distribution has the same mean and variance as the binomial distribution we're approximating. So we subtract the mean of 360, and which is 400 times 0.9, that's where it comes from, and divide by a standard deviation of 6. So what is the variance of this binomial distribution? It's n times p times q. So 400 times 0.9, that's np, that's 360, we just found that, times q, which is 0.1, well, that's 36, and the square root of that is 6. That's where this 6 comes from. And that's now approximately probability that z is more than negative 1.9166667, and that's approximately 0.97, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. It's reproduced with permission, and so it belongs to the SOA. The solution is mine. Good luck in your studies and good luck on the test.